So this video is about multiplying numbers with scientific notation, which is easy to do. The thing we need to talk about connected with this is how many digits to keep when you're finished. It's a question of how precise is the answer when you're done. Now, accuracy and precision are two different things, and you'll find two different sections in the workbook, one about accuracy and another about precision. I assigned homework about accuracy. I did not assign homework about precision because you won't need to know very much about it. Just accept how it relates to multiplying with scientific notation. So I'm going to say a word about accuracy at the beginning of this presentation, just so I can contrast the accuracy against the precision so you can see the difference. Now if I ask you how accurate is 9.5 times 10 squared meters? Well, in ordinary notation, the 10 squared is 100, so it's 9.5 times 100 meters, or 9.5 hectometers. Well, in ordinary notation, it's another 9.5 times 100 gives you 950, so that's 950 meters. But really, you see, we don't know what comes after the 5, because we're assuming here that the number came to us from a measurement with a ruler or a scale or some kind of a measuring device that was limited in its accuracy. And so whoever wrote down this number in their lab book after making the measurement stopped with the 9.5. They did not write another digit after that because they do not know the next digit. So it's not really 950 meters. It's more like 95 question mark. That zero there is uncertain. And we really only know the result to the nearest multiple of 10 meters. We do not know what goes in the ones place. So this is accurate to the nearest 10 meters. Now, let's look at another one. Almost the same thing, but where the exponent is a little bit different. So now, how accurate is 9.7 times 10 to the third meters? Well, in ordinary notation, you take the 9.7 and then times 1,000 meters, and you get 9,700 meters. We started with 9.7 kilometers, and we ended with 9,700 meters, but those last two digits, the ones that come after the 7, are not really known to us. And so the accuracy is really only to the nearest 100 meters. This is different from what we got in the previous problem. So that exponent, changing the 2 to a 3, made a difference in the accuracy. You wanted to say they're sort of equally accurate because they had the same number of digits, but that's not right, because one was hectometers and the other was kilometers. Kilometer is a bigger unit. So there's more uncertainty about the true value with the 10 to the third example. Now, so you cannot determine the accuracy just by looking at the number that comes before the exponential term. But precision is different. With precision, all you have to look at is the number before the exponential term. So 9.5 times 10 squared meters and 9.7 times 10 cubed meters are equally precise because they both have the same number of significant figures. You just When you put it in scientific notation, you'll have one digit before the decimal, and then some number of digits after the decimal. You just count the digits. This is 2 digits. They both have 2 significant figures, and so they're equally precise. What will we use that for? Just one thing. When we multiply numbers in scientific notation, the accuracy of the product, not the accuracy, you forget the accuracy. The precision of the product is the same as the precision of the least precise of the 2 numbers that you're multiplying. So if I want to multiply these 2 numbers, first I use the commutative property to rearrange it a little bit. It's just 4 numbers multiplied, so I'm going to do the 9.5 times the 9.7, and then times the 10 squared and the 10 cubed. I use both the commutative and associative properties to rearrange the operation. And then the meters times the meters makes square meters. Okay, so I multiply those first 2, and I get 92.15. And then I multiply the 10 squared times the 10 cubed, I get 10 to the 5th, and the units are squared meters. And now this is not scientific notation yet, because with scientific notation I can only have 1 digit before the decimal. Here I have the 9 and the 2. I have 2 digits before the decimal. So I need to convert this. I'll divide the 92.15 by 10, so I get just 9.215. I made that 10 times smaller, so I have to compensate. I don't want to change anything because of the equal mark. I want it to be equal. If I take the 92.5 and I make it 10 times smaller to go to 9.215, then I have to compensate by changing the exponent from 10 to the 5th to 10 to the 6th. So now I have 9.215 times 10 to the 6th square meters, or 9.215 megameters. Okay. But I don't know all those digits to be true. My original numbers had a precision of only 2 significant figures, and so my final answer must also have a precision of only 2 significant figures. I need to cut off the 1 and the 5 because I don't know that those are exactly right. I don't know because these original numbers back here might have had something else. It might have been 9.51 really, or 9.53. We don't know what came next. And that's why we don't know what comes next in the final product either. So if you were doing a long calculation, internally, for your own secret use, you would keep all of the digits, but when you come to your final answer, that's when you have to knock it down and not try to report more than you actually know to be correct. Okay. Now the only remaining thing I have to talk about is just how do you enter numbers in scientific notation in Excel. And so if I want to put in that 9.5 times 10 squared meters, I'll type the 9.5, and then I can use a capital E for scientific notation. And it's 10 squared meters, so I'll put in a 2. I hit the Enter key on the keyboard, and it understands that I meant 9.5 hectometers. And I can do the same with the other number. 9.7 times 10 to the 3rd meters. And then if I'm going to multiply, get the product, now I'll say equals, and I don't type the numbers, I click that one, I use an asterisk for multiplication, and click the other one. It gives me a result, but it does not know whether these numbers came from measurement or did they come from, a pure like algebra problem where they would be exactly correct. So Excel does not know whether you want it to round off or not. And so you have to do that manually. And you have this control that I'm pointing at here. I'm in the home menu, and over here in the number group, there's a button to decrease the decimals. And I click that once, and now it's the way I want it to be, 9.2. And so it'll do the rounding for you. And we just learned that you can use the capital E to make scientific notation, that you use the asterisk for multiplication, that you need to start each formula with an equals mark, and I hinted, I didn't really use the hat, but whenever you need to do exponents, if I wanted to do 3 squared, I'd make a formula, say equals 3, and then I use the hat for the exponent and 2, and then it'll say 9. So, that is all for this lecture.